Lesson 5.1, Algebraic Expressions, and our objective is to evaluate simple algebraic expressions. Let's start with our vocabulary. A variable is a symbol that represents an unknown quantity. A variable is a symbol that represents an unknown quantity. Typically, we're plugging in an X or a Y or a Z there, but really it's anything that you're saying, this represents this value. We don't know what the value is, but we're plugging something in there. An algebraic expression, such as n plus 2, is an expression that contains variables, numbers, and at least one operation. And yes, that's a typo. I have on written. It's supposed to be one operation. The branch of math that involves expressions with variables is called algebra. In algebra, the multiplication sign is often omitted. So that's something we've already been practicing. We've been using parentheses. We've been using the dot instead of the X to show multiplication. And that's all part of algebra. Most of you have probably heard your parents say, ooh, I love algebra, or ooh, I hate algebra. Algebra is a love-hate relationship. Very few people are just kind of like, whatever about algebra. You either love it or you hate it. I am the nerd that just loves algebra. Algebra is part of the reason I'm a math teacher, because I was in algebra when I started tutoring my friends and realized I loved it. So, yeah, you'll either love it or you hate it. Hopefully you love it as much as I do so we can get along. Just kidding. The numerical factor of a multiplication expression that contains a variable is called a coefficient. A coefficient. So that is, if I were to have 2x, that would be the number in front of the x. So if I were to have 2x, oh, I didn't switch to pen mode, hold on. If I were to have 2x, my pen is having trouble, sorry. Or I'm having trouble, really, it's not my pen. If I were to have 2x, the coefficient would be the 2. It would be the number in front of the variable. Okay, so we are going to be evaluating expressions. So, number 1 says to evaluate 2 times the quantity of n plus 3 if n is negative 4. So the first thing I do is I rewrite this. So I do 2 times the quantity of negative 4 plus 3. Now, am I and are some of you capable of doing this in your head? Yes, you are. However, little errors will be made if you are not writing it out. So if on a test you were to get it wrong, you would lose more points than if you had just done it the first time by writing it out. So something to think about. So now I have to think of what we talked about last week with order of operations, or GMDOS. I need to start by doing, so what is the first step in evaluating this expression? I need to think of my group, right? So I do negative 4 plus 3 is negative 1. Do I have any exponents left? I do not. Do I have any multiplication or division in order from left to right? I do. So I do 2 times negative 1 is negative 2. And that's my answer. Remember, these questions are down here to guide you. These are questions that you might ask yourself if you were struggling to do this on your own. They're questions that you might use to get it. Number 2, evaluate 3 times the quantity of t minus 4 if t is 6. So I write it out, 3 times the quantity of 6 minus 4. So I do my grouping symbols first. So 6 minus 4, I don't know why my pen stopped working. I do 6 minus 4 is 2. Then do I have any exponents? I don't. So I can use multiplication and division in order from left to right. 3 times 2 is 6. And that cannot be simplified anymore. So I circle it and I am finished. Number 3, I'm going to evaluate 8w minus 2v if w is 5 and v is 3. So I have 8. W would be 5, so I plug it in. When I plug it in, I put it in parentheses. If I don't put it in parentheses, I might think it's 85, which it is not 85. It is 8 times 5. So if I put it in parentheses, it's more clear to me that that's what I'm doing there. Minus 2, again, putting 3 inside of parentheses because 3 equals v. So now I do my GMDOS. Is there anything inside of the groups for me to do? There is not, so I'm done with groups. Are there any exponents? There are not, so I'm done with exponents. Is there any multiplication and division in order from left to right? There is, so I take 8 times 5 is 40, minus 2 times 3 is 6. Is there any more multiplication or division? There is not. So then I do addition and subtraction in order from left to right. 40 minus 6 is 34. Number 4, I have evaluate 4y cubed plus 2 if y equals 3. So I have 4y, and instead of y, I put in 3 cubed plus 2. Now, that cubed is only going to the y. It is not going to the 4. That is a critical thing that a lot of people will make a mistake of. Okay, so I write out my GMDOS to make sure I get all the order of operations, or I can do my wrap. Do I have anything in grouping symbols? I don't. Do I have any exponents? I do. So what is 3 cubed? 3 times 3 times 3. This is 9 times 3. So what is it? 27 plus 2. And then I take 4 times 27, and I'm going to carry my 2. I'm going to get 108 plus 2. And 108 plus 2 is 110. And I stopped this. Oops. I did the exponent to get 27, and then I multiplied and divided to get 108, and then I added and subtracted to get 110. Okay, athletic trainers use the formula 3 times the quantity of 220 minus A, all divided by 5, where A is a person's age, to find their minimum training heart rate. Find Latrina's minimum training heart rate if she's 15 years old. So they said the A standing for the person's age, and Latrina is 15. So we're going to plug in 15 for A. So we're going to do 3 times the quantity of 220 minus 15, all divided by 5. And we do GMDOS. If it helps you, which it always helps me, I'm going to write it out here. We do our GMDOS. Do we have anything inside of the grouping symbols to do? We do. We can do 220 minus 15, which is going to give us 205. And we're going to do all of that divided by 5. Now this is a piece where a lot of people will get tricked. We always, when we have something to do on top and something to do on bottom, we always do what's on top first, and then what's on bottom first, and then solve it, if that makes sense. So we've done our group, we're done our exponent. We're going to multiply, divide from left to right. So we take 3 times 205, which gives us 615, divided by 5. Now we use that division. There's nothing left to do on top, nothing left to do on bottom. So 615 divided by 5 is 123. Marissa wants to buy a DVD player that costs $150. She already saved $25 and plans to save an additional $10 each week. Write an expression that represents the total amount of money Marissa has saved after any number of weeks. So this starts out by talking about the DVD player, but really that information means nothing to us right now. The fact that the DVD player costs $150 and the fact that she wants to buy it means we don't care. We don't care about Marissa and her DVD player right now. All we care about is finding an expression that will show us how much is she saving after any number of weeks. So how much has she saved after 1 week? How much has she saved after 200 weeks? How much has she saved over a year and 52 weeks? It doesn't matter. Like, we just want an expression to know after any amount of time we could find out how much money she'd saved. So she saved 25 ahead of time. Like, grandma gave her money for Christmas or something. We don't know where that money came from, but she has $25 already saved in her bank account. Then she gets $10 every single week. So if we take $10 times the number of weeks that she's working, add it to the amount grandma gave her for Christmas, we have how much money she has. So that's our expression to show us how much money Marissa always has. The word each here is critical. the word each, if I can underline it. The word each is critical. It's showing us multiplication. So if she's making $10 per hour, that's multiplication. If she's making $10 each week, it's showing us every hour she works, she's getting $10, or every week she works, she gets $10. It's showing you every single time. So that's going to be a multiplication. We wouldn't multiply the 25 by the number of weeks that she's working, because that wouldn't make sense. Grandma gave her that money one time. It's done. It's over. She has that $25 saved. It's not a part of her weekly savings. So that's why it's just added on without any multiplication to it. Okay, based on example 5A, Marisa have saved enough money to buy the $150 DVD player in 11 weeks? Use the expression. Now we care about her DVD player. We didn't care earlier. Now we do. So we're going to take 25 plus 10 times, we're talking about 11 weeks. So how much money will she have in 11 weeks? So we plug that in for W, because the W stands for weeks. And then we do GMDOS. Is there anything inside of the groups to do? No. Are there any exponents to do? No. Is there any multiplication or division to do? Yes. So I take 10 times 11, which is 110. So I take 25 plus 110. And then I add those together, and I get $135 is what Marisa will have in 11 weeks. Is that enough money for her to buy that DVD player that costs $150? Sadly, it is not. Marisa does not get to watch her favorite movie, Frozen, tonight when she gets home, because she cannot afford a DVD player.